Right, so the topic that we will be dealing with today would be quadratic functions and completing the square. So, a quadratic function models situations where something increases, then decreases, or vice versa, meaning it decreases, then increases, right? So, the graph for a quadratic function will literally be called, well, it is called a parabola, right? So a parabola is the U-shaped or the N-shaped curve, right, Jordan? You get when you graph a quadratic, right? So the U-shaped or N-shaped curve you get when you graph a quadratic is called a parabola, right? So a quadratic function is written in the form y is equal to ax squared plus bx plus c. But I want you all to also note that y and fx mean the same thing, right? They are equal. But a quadratic function can also be written as f of x is equal to ax squared plus bx plus c. Everybody clear there? Now, some things to note here. When this value a is greater than 0, meaning that it is a positive, the curve is a minimum, meaning that it's decreasing then increasing, a minimum curve. When a is less than 0, meaning that it is a negative, the curve is a maximum curve, right? This is a valley above here. This is a mountain. Think mountain and think valley when you're dealing with this, right? So for a quadratic function, f of x is equal to ax squared plus bx plus c. C is the y-intercept, right? Y-intercept simply means it's where... Hold on. Y-intercept simply means that is the value on the y-axis where the curve cuts through the y-axis, right? Scrolling down. Axis of symmetry, right? Symmetry is basically a symmetric line is basically a line that cuts a shape or anything into two equal pieces, right? So the axis of symmetry is the equation of a straight line that cuts the curve into two equal parts. I have a minimum curve here, and I have my axis of symmetry cutting it into two equal parts, right? So the equation for this axis of symmetry will be x is equal to negative h, right? Where h is equal to b over 2a. Everybody locked in there? Lock in. So turning point or your vertex, right? The turning point is the maximum or minimum point of the parabola, right? So at the base here, the lowest point on your curve would be the minimum point here. The highest point on this maximum curve will be the maximum point here. Bottom are the valley, top of the mountain, right? So your maximum or minimum point is given by negative h comma k, right? Completing the square. So to complete the square means to turn a quadratic into a form that shows the turning points easily. What are the turning points? Well, it should be the coordinates of the turning points that show put in the word coordinates here. The coordinates of the turning point, right? So completing the square is a form that you can see the coordinates of the turning points easily, right? So if you have a quadratic function, and that is f of x is equal to ax squared plus bx plus c, the completing the square form will be f of x is equal to a, open brackets, x plus h squared plus k. There are many ways to complete the square. The one that we would use is I have a formula for h, I have a formula for k. Use the formula for h, you will get this value here. Use the formula for k, you will get this value here. What is a, b, and c? You get that straight from your quadratic. A, b, and c. We good there, my brothers and sisters? We good there, right? Note, the maximum or minimum value is the value of k, right? So anytime a question asks you for the maximum or minimum value of the quadratic, they simply asking for the value of k. The coordinates of the y-intercept would not just be the value of c. The coordinates of the y-intercept would be 0, comma, whatever c is, right? The values of the x-intercepts are called the roots of the quadratics, right? So if I ask you for the roots of the quadratics, it means I want the value of these two x-intercepts here. right? So I just indicated that this down here would be my turning point. I indicated that here would be my y-intercept. Everybody have everything locked in there? Let's go. So your quadratic formula, which is the last note I gave here, is basically just x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So we have all the ammunition necessary to attack these questions, right? So let's attack. So question 1, express the quadratic function f of x is equal to 3x squared plus 6x minus 2 in the form a open brackets x plus h squared plus k, where a, h, and k are constants, right? So what form is this again? This is the completing the square form, right? It allows you to see the values of the coordinates for your turning point, right? Everybody clear there? So let's first identify what A, B, and C are. Could somebody give me that? A would be equal to 3 is the number in front, x squared. B would be equal to 6. And C would be equal to, from here on out, it's full onslaught because they have formulas to deal with this, right? So let me go. We want to find the value of H. We want to find the value of K, right? So let's go. H is equal to B. All it's not supposed to be written for me here. B over 2A. And on this side, we'll do K. K is equal to 4AC minus B squared all over 4A, not 2A. 2A is the quadratic function, right? Let's work. Send this down. All right. So
we mean 4 AC.
Right, so let's work. H would be equal to B is 6 over 2 by A, which is 3. Proper thing. This will be 6 divided by 6. H will be equal to uno. Ducks. We winning or we losing? Let's go. Right? So 4 by A. What is A? A is 3. What is B? No, C, sorry. C is negative 2 minus B, which is 6 to the second power all over 4 by A. How it looking? We winning or we losing? So on your calculator, you're going to put 4, open brackets, 3, close bracket, open bracket, press the plus or minus knob to get minus 2, close bracket, minus, open bracket, 6, close bracket to the second power. How do you access the second power? X to the second power, right? Press equal, tell me what you get. Negative. So this will be equal to negative 60 divided by 4 3s are 12. Remember, brackets imply multiplication, right? So this will be equal to negative 5. That's the value of K. We winning or we losing? There's no way to lose here, boy. None. If you lose, it's because you want to lose. So therefore, A, open bracket, x plus h squared plus k, which is what the question asks us to do first, would be what? What's the value of A? A is 3. Open brackets, x plus h, which is 1 to the second power, right? And it would be plus negative 5, right? But a plus and a minus will give me a minus. How to lose notes, eh? So this question said, this part of the question said, hence or otherwise state the minimum value of the function f of x, which is equal to 3x squared plus 6x minus 2. I gave you all that note right up here, right? Look at this here, my children. The maximum or minimum value is the value of, so that's all I'm writing. So I'm writing the minimum value would be negative 5. So this part of the question said to state the equation of the axis of symmetry of the function 3x, well, the same function, 3x squared plus 6x minus 2. So the equation of the axis of symmetry is given by what? X is equal to, I'll have it right in all your book. X is equal to negative h, proper thing, right? So x will be equal to, what is the value of h right in your book there? 1. So this will be negative 1. Talk done. I don't even have nothing else to see here. So sketch. You see that word sketch? That word is a very important word here. Sketch means you're drawing freehand. We'll put a note on that. Put a note somewhere, guys. Note. Sketch, because this is important. I don't want to looking for graph paper or reason or hand. Excuse the examiner, how I didn't get graph paper and they want us to draw a graph here. Sketch means to draw conducts. Freehand.
Let's get the graph paper on the exam thing itself.
If it are graphs to draw. So y'all realize for this part, they actually wrote your graph as y, right? They wanted to sketch a graph y. They did not use f of x, but I already told you all that f of x is the same as y and vice versa, right? F of x is y, okay? So if I put y here, it come like the right f of x, okay? So this is the function that we had above. And on your sketch, they want us to show the intercept on the y-axis. What is the intercept here on the y-axis? Is the value of c. What is the value of c? C is equal to -2. Proper thing. They also want us to show the coordinates of the midpoint. The coordinates of the midpoint would be given as -h, k. Right? Make sure you're with me now. Right? So there we go. What was -h here? It would be -1, -5. Proper thing. So on my sketch, this is all I need to show, right? So for your sketch, right? Sketch boss docs, right? So we go in. Y-axis, boom. X-axis, bang. So I'm going to plot what we want to show, right? We basically want to show -1, -5. -1 will be somewhere here, -1. I want to make some space on it here because -5, I think I want to go a little lower than what I showed there. So for -5, we're going to bring this down a little more. Boom. Right, so -5 will be somewhere quite down here. Everybody agrees? -5. So that coordinate will be somewhere here, right? And what is the the y-intercept? It is -2. So -2 will be somewhere here. Everybody agrees? It's a sketch, so it's just a gauge. Obviously, you ain't gonna put -2 up here, right? You ain't gonna put -2 quite down here. It's a gauge, right, my children? So I reason this, right? So I plotted my minimum point. Now, I am going to just put a dot here to indicate where my y-intercept will be. So what you're doing is going to be a sharp curve, right? You're not drawing this curve as a V, eh? You're drawing it as a U. So you're coming on here. Wait. What's that? Father. Right, we're coming on here, boom. Huh. I like how that look like that, huh? Let me pause this thing until I get. So my curve came down here. It's a minimum curve, so you come down, right? It's decreasing. You went straight down to your minimum point here, and then you go back up, passing through your y-intercept -2 and going straight up, right? Points to note, do not V your curve. If your curve looks like this, you're not getting any marks in the people exam, right? So they want us to state the roots of the equation. The roots of your equation would be the values of your x-intercepts, right? But to find the roots of the quadratic equation, you must solve the quadratic with y being equal to 0. I put with, it should have been when. Change this to when. Right, so this is when y is equal to 0, okay? We have our quadratic here, which is 3x squared plus 6x minus 2, and that will be equal to 0 because y is 0, okay? I just put an additional note here. On the x-axis, y is equal to 0. Are we clear here, my children? Try to show you how it works. So you can try factorization first. Sometimes they ask you to solve a quadratic using factorization. Sometimes they ask you to solve a quadratic using the quadratic formula. So wherever they ask you, you have to use. But if they don't ask you, you can use either one. Right? So watch it.
This question you're doing right now is for IB.
Say that again. So watch how quadratic factorization would not work, right? 3 multiplied by negative 2 will give me negative 6. And the number we put in underneath will be the middle number here, which will be positive 6, right? Are there any two numbers that can multiply to give you negative 6, and the same two numbers must add or subtract to give you positive 6? Not 3 and 1. 3 and 2. 3 multiplied by 2 is 6, yes, even if you put 1 as negative, right? 3 multiplied by negative 2 is negative 6, but 3 minus 2 is 1. That cannot work, right? So 6 and 1, 6 multiplied by negative 1 is negative 6, but then 6 minus 1 will be 5, right? So we're going to write here not possible. Even if you do it in CXC, don't scratch it off, just put not possible, roll into a quadratic formula, right? So I'm going to put A. What's the value of A? A is equal to, B is equal to, and C is equal to
negative 2.
hit my quadratic formula. X is equal to
minus b plus or minus the square root of 4
B squared.
minus 4ac over 2a.
2A. Alright? Okay? This formula is totally different to the formula for X. Alright? So let's work. We work it. X will be equal to negative 6. Everybody good there? Plus or minus the square root of 6 squared minus 4 by 3 by negative 2 all over 2 by 3. So let's simplify what is under the square root sign there, right? So x will be equal to, I put it back in negative 6, I put it back in plus or minus.
Be in bracket there or
No, 6. Yeah, don't make that better. 6. That's our 6, right? 6 squared will be 36. And then when you work out 36 plus 24, this works out to be, you will get positive 60. All over 6. 2 3s are 6. Right? Now, when you reach a stage that there's nothing else you can simplify, you cannot say 6 into 6, 1 there. You branch off into two answers. So you come in here and you come in here. Cool? So the first one is going to be x is equal to negative 6 and you're using the plus. That 6 can be negative 6 plus the square root of 60 all over 6. And on this side, x will be equal to negative 6 minus the square root of 60 all over 6. Give me my answers to two decimal places, please. X will be equal to... So my two answers here, the first one will be x is equal to 0.29. Now guys, something we need to practice is you need to put 2 dp, yeah? We need to practice to putting these things to 2 dp. Okay? Put in that, please. That is very important.
you can scroll up a little bit.
Express the quadratic function 2x squared minus 3x plus 1 in the form a open brackets x plus h close bracket squared plus k. First things first, what do we call this form? Let's just get these things completing the square form, right? And this form here, what this form is? Quadratic form, right? Get them things in your brain, lock it in, right? So, in order to express a quadratic in completely square form, I gave you all two formulas to find, one to find h, one to find k. Let's write that down first. That's where you should start. H would be equal to, what is h equal to? B over 2a. B over 2a. What is k? I gave you all a formula for k. What is k?
4ac minus b squared over 4a.
Right. Compose yourself, right? You know you have to have a value for A, you have to have a value for B, and you have to have a value for C, right? Now, I should say this one time. If you are not given any A or any, well, you would not be given any A, but if you are not given any B or C, right, it will actually be B will be 0 and C will be 0. Like say this question didn't have a C, C will be 0, right? But anyway, we haven't reached our question like that yet. So let's go. I'm going to write it above here. A will be equal to 2. B will be equal to negative 3. Not 3, negative 3. And C will be equal to 1. Everybody good there? Let's work, right? Compose yourself. So A should be equal to B, which is negative 3 over 2 by 2. Everybody good there? This will mean that H is equal to negative 3 over 2 twos are 4. Proper thing. Right? We go in here now. K would be equal to 4 by 2 by 1 minus negative 3 in bracket squared all over 4 by 2. Compose yourself. Right? I keep telling you all, this is a whole game of composure. Right? So you're composing yourself now, you're going to your calculator, you're typing out this whole thing on top here. Right? Now when you put in this minus sign, right? When you put this minus sign, that is not going to be like minus. Okay? That is going to be the plus or minus knob, which is negative, right? So you put open brackets when you reach here, and then you press the plus or minus, plus slash minus knob, and you'll see a little baby negative come out, and then you press 3, you close your bracket, and you press square. When you work out that whole top, what are you all getting there? Negative 1 over 8.
So, you know, I got it. Balik sa ka, like,
So this one, using your answer above or otherwise, calculate the minimum value of the quadratic, right? So the minimum value is the value of K. So K will be equal to negative 1/8, right? You should actually put minimum value
So 0.125
is equal to negative 1 over 8, right? We done there. We move in one time, right? Important. So next we have the value of x for which the minimum value occurs. This is simply the equation of the axis of symmetry, right? So the equation of the axis of symmetry is the value of x, right? So what else? Lucky. We ain't come here to lose. So the equation of the axis of symmetry would be x is equal to negative h, right? So this is what I was explaining to you all while we were doing it. X is equal to negative of negative 3/4, right? And what's negative 3/4?
For sure.
Right. So a negative and a negative will be a positive. So x will be equal to 3/4, right? So sketch the graph of y is equal to 2x squared minus 3x plus 1. Show on your sketch the intercepts on, well, the intercept on the y-axis. What's the value of c? Let me just write it here. What's the value of c? And negative, positive 1, right? Now, the coordinates of the minimum point. That will be given by negative h comma k. And this will be, we already wrote negative h as positive 3/4, comma, k would be negative 1/8. Everybody good there? And they also want the values of x where the graph cuts the x-axis. This here, they are asking us to show the roots. Right? They want the roots of the quadratic. Right?
That is x.
That's the value of x. So we want the value of x. Okay? The values of x where the graph cuts the x-axis. This will be the roots of the quadratics. So I'm going to try to solve it using factorization first. I think I actually seen you can use factorization here. Right? So watch it. 2 multiplied by 1 would give me what?
So you got
Positive 2, right? Then the number that is in the middle goes underneath, which is negative 3. Not positive 3, negative 3. So what two numbers can multiply to give you positive 2, and the same two numbers can add or subtract to give me negative 3? It would be negative 2 and negative 1. And negative by negative is a positive. 2 by 1 is 2. And then negative 2 minus 1 will give me negative 3. Everybody good there? It works. I'm gonna write it here because men watch me like they never see this before.
Jiggle.
So watch it. This here is -2 multiplied by -1. You get +2, right? Oh, I lucky, you know. I don't play in my classes, you know. Right? So there we go. Here will be -2 minus 1, which will give me -3. Right?
Those things.
Put the x here one time, so you put x, right? So these two things would be replacing this minus 3x here. So watch how this would look. 2x squared minus 2x minus 1x, which is just x, plus 1 is equal to 0. Everybody good there?
Like gold.
So when we have 4 terms, how much do we factorize at that time? 2. So I put a little line in the middle here. What could go into 2x squared and 2x? 2x. Right?
Don't forget.
2x, 2 into 2 cancels. X into x squared would leave me with x. 2x into -2x will be -1. 2x into 2x is 1, and then remember it's negative, right? Bring down this minus sign. The only thing that could go into x and 1 would be 1. -1 into -x will give me positive x. Then -1 into +1 will give me -1. This will be equal to 0. The two brackets become 1. And then what is in front of this bracket and what is in front of this bracket forms the next bracket. Everybody good there? Right? So this here is my quadratic function after I factorize it. I still have to solve each one of these brackets separately to get the values of x. So watch it. We go in here, we go in here. So I'll have x minus 1, which is what is in the bracket, is equal to 0. Right? Then on this side, we're going to have 2x minus 1 is equal to 0. Carry this minus 1 over here. Do the opposite of minus, which is to plus. X will be equal to 0 plus 1, which will be 1. And then 1 comes here. 2x will be equal to 0 plus 1, which will be 1.
1 divided by 2.
Carry the 2 here divided. X will be equal to 1/2. Right? Okay? 1/2. These things, these values of x here would be the roots of my quadratic, right, Jordan? The roots. Okay, the roots of my quadratic function would be equal to, well, will be x is equal to 1 and x is equal to 1/2. So we put in the roots. Go ahead. Go ahead, Annie. Right, so we have the y-intercept, which is c. We have the minimum, the coordinates of the minimum points, which will be 3/4, comma, -1/8. We have the roots of our quadratics. We have to show these 3 sets of things, right? So let me draw my x and y axis, because this is going to be a lot here. So you're draw it. You have your y-axis, boom. Then you have your x-axis, bang. Right? Compose yourself. Let me put in the y-intercept. What's the y-intercept there, Ramo? Is the value of c. C is what? 1. Right? Boom. Then, let's put the coordinates of our minimum point. What the coordinates would be? It was positive 3/4 on the x. So let me say positive 3/4 is somewhere here. And -1. Alright, so 3/4 here and -1/8. Let me call that here. -1/8. Right? You know to be somewhere there's zeros in the middle here, right? So that coordinate will be here. So give me the x-intercepts now. I believe one of them was +1, which will be on this side. Everybody agrees? +1 here. Cool? And then you have +1/2, which will be right on this side. Okay? So you all see the heights here? So there we go. We coming down. Boom. Hey. So, what did I do here? I came down, I passed through the y-intercept, draw this dots, draw it. You tell me use the sketch boss, right? So this is your y-intercept, right? You come down here, you bust through 1/2 because this 1/2 is one of the roots, right? This is one of the roots of your quadratic, and then this next one here will be the other root of your quadratic, and then you have 3/4, comma, -1/8. That will be your minimum point, which is here. Okay? Proper thing. So number 3, they said, write 3x squared minus 12x plus 8 in the form a, open brackets, x plus h squared plus k, where a, h, and k are constant. They probably have somebody in there, bro. So there we go. You want to write a quadratic in completing the square form. Everybody good there? What do we have? We have two formulas, right? But let's write what a, b, and c are first. A would be equal to, b would be equal to -12. C would be equal to 8. Let's work. So therefore, we have h. H is equal to b over 2a. K is equal to 4ac minus all over. Come on, guys. This is something we should know how to do. I see men writing. That means we didn't do it. Right? So there we go. H will be equal to 3, no, not 3, 12. 12, -12, -12 over 2 by 3. This will be h is equal to -12 divided by 6 will give me -2. K will be equal to 4 by 3 by 8 minus -12 squared all over 4 by 3. What do you get with the top? For the top, when you work out the numerator. -48, proper thing. -48 divided by 12. That's what we're talking about. -48 divided by 12. K will be equal to,
Screen a little smaller, please.
sure, -4. Right? So we found h, we found k. So therefore, a, open brackets, x plus h squared plus k can be written as, what is a? A is 3, x plus, no, it will be -2. Not +2, because it's plus -2, which will be -2, squared, plus -4, which will be -4. This here would be our quadratic function in completing the square form. Talk to me, Levi. Right, so they want us to sketch the graph y is equal to the quadratic, which is 3x squared minus 12x plus 8. We know that on this y-intercept, we should need on this sketch, we should need y-intercept, which is 8. C is equal to 8. Then the coordinates of the minimum point, which will be 2, -4. That is all we should. So let me go. Boom. Bang. It's a sketch. So you join us freehand. So you're going 0, 2 on the x. Let me put that here. 2 here. You're good there, Ramo? Huh? No? You don't know what to do here? Alright, let me plot the point. Watch it. So you see this is the minimum point, right? So when I put in coordinates, right? This is 2 on the x-axis, Ramo. This is your x-axis, right? So +2, remember you'll have 1 here and then 2 would be here, right? Then on the y-axis is -4. Remember your negatives on the y-axis. This is your y-axis. Your negatives will be going down, right? Tell me comment now. So -4 will be down here. Cool? Right? So if I need to plot the point, it will be where +2 and -4 meet. You good there, Ramo? Right? So that is my minimum point. Sing, you have a question? Minimum point. So the only other thing they want us to show is your y-intercept, which will be quite somewhere up here, which is 8. Right? +8 is somewhere quite up here. So we come in. You're coming through here, boom. You're coming down, bang, and you're going up. Talk done. Right? You know what I didn't do above and you need to do? You need to put y is equal to x squared, 3x squared, sorry, minus 12x. You need to label your curves here. Let me I go back up and label all. Plus 8, right? You had to label your curve, right? I'm just scrolling up to label the rest. Okay? That's something I didn't do. This one was what? This one was y was equal to what, boy? This one is y is equal, look at here. Y is equal to 2x squared minus 3x plus 1. Y is equal to 2x squared minus 3x plus 1. How much more curves we did? We didn't do our curve up here somewhere? Right. What this one was? Look at right there. Y is equal to 3x squared plus 6x minus 2. The question is simply asking us to express a quadratic, which is x squared minus 3x minus 12, in the form y is equal to, they did not put any a, right? But the last day we did a question like this. So you all know the reason why they did not put a is because what number is understood in front of this x squared? 1. So 1 is understood here. So CXC did not bother to put a because 1 will be understood here also. You don't need to put it, right? So they want you to write this quadratic in this form, right? Where h and k are constant. Somebody remind me, what do we call this form? This is called what? Completing the square form, right? Winning season, right, guys? So let us do that before we even jump into any question here, right? So I have formulas for h and k. So I'm going to write my, actually first, let me write what a is. A is equal to 1, b is equal to negative 3, and c is equal to negative 12, right? Where did I get these things from? I got it from the fact that this is a quadratic in the form ax squared plus bx plus c. All it means here is that this b would be negative 3, c would be negative 12, and a would be 1, which is understood in front of my x squared there, right? I'm saying it again. Nobody should get any completing the square question wrong, eh? H is equal to b over 2a, food, right? K is equal to 4ac minus b squared all over 4a. I tell all you, if we cannot get over this hump, leave my class, eh? I'm real serious, eh? This is serious business now. So at this point in time, the question becomes a substitution question, right? So h would be equal to what is b? B is negative 3. You simply replace b with negative 3. All over 2 by what is a? A is 1, right? So h will be equal to negative 3 over 2. Simple as that, right? Let us write it as a mixed number, right? So h will be equal to negative 1 and 1 over 2. Everybody good here? We winning, right? Very good. You can write. So there we go. K is equal to 4 by 1 by negative 12 minus negative 3 to the power of 2 all over 4 by a, which is 1. When we work out our numerator here, what do we get? We ain't come here to stick, guys. You cannot come and say that a negative by a negative is a positive here, right? Because you have to work out the brackets first. So you have to work out this entire thing first, and then you would say negative of whatever you get there. Are we clear? Right. So when you work out the top, you will get negative 57 over 4. And this could be written as a mixed number to be what? Negative 14 and a quarter. Right.
So 14.25.
Is not finished, right? So let's go. We need to write that quadratic that we have above. By the way, what form do we call this again? Huh?
No,
This is quadratic form. Thank you. Quadratic form. And this here would be completing the square form, right? So let's write it in completing the square form. They didn't put an a, they just put x plus h squared plus k is equal to x plus negative 1.5, which will be minus 1.5, close brackets, squared, plus k, which is negative 14 and a quarter. So I would put minus 14 and 1/4 one time. How we look? Hence, determine the minimum value. They never said the minimum point. They said the minimum value of the function y is equal to x squared minus 3x minus 12. My minimum value is the value of proper. My minimum value is the value of k, which is negative 14 and 1 over 4. Right? So the minimum value of a quadratic function is the value of k. Lock that in your brain, right? So we're going on to part B. Correct to one decimal place, I need you to write the roots of the equation. The roots of my equation would be the values of x, right? Your x values when you solve the quadratic, right? So let me put a little note to that effect. So the roots of a quadratic equations are the values of x when y is equal to 0. Where is basically where the curve cuts through the x-axis, right? Cristiano, lucky. So in order to solve this quadratic, which is basically what you have to do, also remember something. Remember they said to one decimal place, right? So in order to solve this quadratic, I will need to take the quadratic and equate it to 0 because it's basically when y is equal to 0. So I'm going to rewrite the quadratic as x squared minus 3x minus 12 is equal to 0, right? Can this be solved using quadratic factorization? It cannot. It cannot. Watch it. If you multiply this by this, what you will get? You will get negative 12 because 1 multiplied by negative 12 will give me negative 12. What number goes underneath the x? Negative 3. The number in the middle is what goes underneath, right? Okay? This number is what comes here, right? Now, you're looking for two numbers that could multiply to give you negative 12, and the same two numbers must add or subtract to give me 3. It's basically 4 and 3, 12 and 1, well, 6 and 2. Any of those numbers could even minus to give us 3? No. So, quadratic factorization is not possible. So you know what we need to go to? We need to go to the quadratic formula, all right? The quadratic formula. Hill, you have a question?
B squared take away 4ac all over 2.
So let's go. Quadratic formula, right? X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a, right? Points to note, we have the values of a, b, and c. A is equal to 1. Look at it right above there. A is equal to 1, b is equal to negative 3, and c is equal to negative 12, right? Are we looking? So, I'm going to substitute my values into this quadratic formula now, right? So x will be equal to negative of negative 3 because b is negative 3, right? Plus or minus the square root of b squared, which is negative 3 squared, minus 4 by 1 by a. Well, a is 1 and c is negative 12 all over 2 by 1, right? Let's simplify some stuff here, right? So x will be equal to negative, and a negative is a positive proper thing. So I can just write positive 3 here, or just leave it as 3, plus or minus the square root of what do I get when I work out underneath the square root here?
9 plus 48.
9 plus 48, which should be positive 57. Yeah. Positive 57 all over 2.
So I get 7.55 when I don't got all that.
Yeah, okay.
Saying it again. If you go on your calculator and you punch in the working without putting the top in brackets, you would get the wrong answer. Right? So look at how it would look here, right? I'm going to now branch off into two separate answers. One side I would have addition, one side I would have minusing, right? So I come in here first. Boom. Right? So I would have x is equal to 3 plus square root of 57 all over 2. You must work out the top and put it in brackets. And then press division and 2. Then here, branch it off here now. I would have x is equal to 3 minus the square root of 57 all over 2, right? I add on one side and I minus on the next, right? Must this, right, go ahead. What you get here? X will be equal to
5.3.
5.3. Remember, it's the one decimal place, my children. And x will be equal to 2.3. So therefore, the roots.
So negative 2.3, huh?
Yeah,
Oh, yeah,
negative, correct. Negative 2.3. Quadratic would be x is equal to 5.3 and x is equal to negative 2.3. We are sketching, which means we are drawing freehand, right? So sketch a graph of y is equal to x squared minus 3x minus 12, which is the same quadratic, showing clearly the value of x where the function is a minimum, right? So I want you to write a note on the value of x when the function is a minimum, right? So if a question asks you for the axis of symmetry, they could either ask you for the value of x where the function is a minimum or maximum, or they could just ask you straight up for the equation of the axis of symmetry. So on this sketch, they want us to show the value of x where the function is a minimum. They simply want us to show the equation of the axis of symmetry, right? That'll be x is equal to negative h, right? So x will be equal to negative of what h was? I think it was negative something.
Minus 14.1.
H,
No, hang on.
H is 1.5,
1.5.
right? So a negative by a negative would give me a positive. So to show this axis of symmetry is simply going to be a line that goes through where x is 1.5. Proper? Right? That's the first thing they want us to show. They want us to also show the x-intercepts, which are also called the what? So the x-intercepts are simply my roots. And we just found the roots here, my children. What are the roots? Let me write it right here. X is equal to 5.3 and x is equal to negative 2.3. So let's do our freehand sketch, right? So I did a rough sketch of my Cartesian plane, right? Remember, these things are approximations we're basically doing, right? They don't need to be perfect, okay? It's a sketch. So let me see. My roots would be 5.3 and negative 2.3. So let me see if I could. 5.3 will be somewhere here, boy ducks. 5.3 and negative 2.3 will be closer to 0 on this side. So let me see here. You get that, Emmanuel?
Yeah.
2.3, right? So that, go ahead. So I put my x-intercepts and I'll need to draw the curve to show the axis of symmetry, which will be a straight line coming to the center. So you know what I want to do? I want to write down the coordinates of the minimum point. Who can remind me what the coordinates of the minimum point would be given by? Note. So write it down. The question did not ask us to show the coordinates of the minimum point, but I'm just telling you all that the coordinates of the minimum point is given by negative h comma k. So watch out this bad boy go and look at. I go and show it in red. You're coming down here. Boom. Busting through here. Coming down here. Going up here. Bang. Everybody good there? Now, if I want to show the value of x where the function is a minimum, which is this, I want to basically show that x is equal to 1.5. It's going to be a straight line coming through 1.5. Okay? So we're going to start from the top, come down here, boom, boom, bang. That there, let me carry it around a little bit. That there would be the axis of symmetry. Okay? I'm going to label this now. X is equal to 1.5. I'll label this also. Y is equal to x squared minus 3x minus 12. Right? So they did not ask us to show the coordinates of the minimum point, so I don't need to put it in. But the coordinates of this minimum point would have been negative h, which will be negative of negative 1.5, comma, negative 14 and a quarter. which is what we worked out above, right? So a negative and a negative would have been a positive. This is like just a bonus to the question. So this will be 1.5, comma, negative 14 and a quarter. I just want to show you how the question making sense, right? And negative 14 over 4 will be somewhere quite down here. Negative 14 and a quarter, sorry. That's somewhere quite down there. And then positive 1.5 would be here. So you see how the coordinates of the minimum point lining up? Right? And then the y-intercept was what? The y-intercept was like negative 12, which would be a little high up. So I could have drawn my curve a little more defined, right? But negative 12, which is the value of C, would be your y-intercept. Is everybody clear here? Are we clear? Some all with me like a year now, right? And all will hear me singing shout this year. This is a whole composure game, right? Compose yourself, use the information you know. You have your quadratic above here, right? F of x is equal to 2x squared plus 4x minus 5, right? We know what A is, we know what B is, we know what C is from this quadratic. Let's write it. A will be equal to, B will be equal to, and C would be equal to, right? So they want us to write this quadratic in what form? What do we call this form? Completing the square form. You know why I keep driving that statement home? Because sometimes CXC won't even ask you to write something in that form. They just ask you to complete the square. And you had to know when they say complete the square, that is this form you had to write it in. You have to remember this form. So let me go. H would be equal to B over 2A. K would be equal to 4AC minus B squared over 4A. Right? So we have to. So let me go. H would be equal to 4 over 2 by 2. Right? It had any negatives here? Just the 5 was negative. Right? So 4 divided by 4 would be 1. Let me go here now. K would be equal to 4 by 2 by negative 5 minus B squared, which is 4 squared, all over 4 by 2. Right? So this will be equal to, what would we get when we work out the numerator here? So this will be equal to negative 56 divided by 4 twos are 8. So K would be equal to what? Negative 7. So you could lose marks if you do not complete what CXC asked us to do, right? CXC asked us to write it incomplete in the square form. They did not ask us to find H and then find K alone. So I will put here now, therefore, A, open brackets, x plus H squared plus K. Please memorize this, because as I said, sometimes CXC asks you to just complete the square. And they don't give you this, right? So, let's write this a little better. Key, right? So this will be A. What was A? I think A was 2. 2 open bracket x plus 1 squared plus negative 7, which will be minus 7. Anybody good there? This here is my quadratic in completing the square form. Alright? So the thing about completing the square form, you all know what this form was for? That was one of the first notes I gave you all. It's a form that we change our quadratic to so that we could see the coordinates of the minimum points clear. Right? Right? State the equation of the axis of symmetry. The equation of the axis of symmetry is given by x is equal to negative h. Right? So this will be x is equal to negative 1. You lost a whole mark there. Right? By just not doing that. That mark. And next mark you lose was state the coordinates of the minimum point. The coordinates of the minimum point will be given by negative h comma k, right? And that will be negative 1 comma 7. Is negative 7? A whole next mark you lose there. Well, they want you to know, sketch the graph of fx. But on the graph, they want you to clearly show your minimum point, which was what? Negative 1 comma negative 7. Clearly show that, right? And the axis of symmetry, what the axis of symmetry was given by x is equal to negative 1. Right? That's all we need to show. So we go in. Y-axis. I put in my x-axis a little higher because I don't see it's -7 out of show.
Yep.
Right? So this is my x-axis. Freehand because they said the word sketch. Right? So we go in 0 here. Minimum point. Where would -7 be on your x-axis? Remember, the coordinates. For the coordinates, your first coordinate would be x. Your second coordinate would be y. Everybody good there? Let's work. So this would now be -1. What is -1 here? And it's going to be here?
Yeah.
-7 will be somewhere quite down here. Cool? So the coordinates, watch it there, Kemiel, because you said you get problems with this. Your coordinates will be where the two numbers meet. Where they meet is where your coordinate would be. Right? So that coordinate would be down here. Bang. And the only other thing they want us to show is the axis of symmetry. So I'm going to just draw my line coming down here. So bow, when I'm align my curve, come through here, go up. Right? That's my curve. Axis of symmetry is a straight line coming through where x is -1. Boom.
Oh, kitchen now.
Yeah. Catching it?
Yeah, kitchen.
Must catch it, bro. We ain't come here to lose, you know. Right. So it must pass through where x is -1. This here, let's put the coordinate, not the coordinate, let's put the equation of the line. X is equal to -1. And what is the equation of the curve? Y is equal to, what was 2x squared plus
4x subtract
4x. That was seen as Busara. 4x subtract 5.
Yep.
Proper. The last part of the question is simply asking us to find the values of x where the curve is cutting through the x-axis. That will be the roots of my quadratic, right? So in order to find these roots, something you'll need to understand is on the x-axis, the value of y would be 0. So I'm going to rewrite this quadratic as 2x squared plus 4x minus 5 is equal to 0. So we're going to solve this now in order to find the roots. Quadratic factorization can't work here. Let's jump straight into quadratic formula, right? So A will be equal to,
2,
B will be equal to,
4,
C will be equal to.
5.
Quadratic formula is x is equal to -b plus or minus the square root of
B squared
minus 4ac all over
2A.
2a. Right? So let me go. X would be equal to -4 plus or minus the square root of b, which is 4 squared minus 4 by 2 by -5 all over
2 by 2.
2 by 2.
So you could zoom in your camera a little bit. I mean, zoom out.
Zoom out, sure. So this would be x is equal to -4 plus or minus the square root of what? What we gonna need there? What? So when you work out under the square root, you would get 56, right? So what you need to do here now is you need to work out the top divided by the bottom when we branch off. Well, after we branch off, right? So we're gonna branch off here. Boom, bang. We branched off into two answers, right? So here we'll have x is equal to -4 plus or minus, no, not plus or minus. We're just using plus on one side and minus on the next. So plus square root of 56 over 4. And on this side, you'll have x is equal to -4 minus the square root of 56 all over 4. X will be equal to what? And on this side, on the first piece here, x will be equal to what? Work out the top is either two things. It's either you work out the top, press equal, and then divide by 4, or you put open bracket, put what is on top, close the bracket, then press divided by 4, and you will get 0.87 on the left, and you'll get -2.87 on the right. Okay, so number 6, write the function f of x is equal to 3x squared minus 5x plus 1 in the form a open brackets x plus a squared plus k, right? Where a, h, and k are constants to be determined, right? So let me just ask some simple questions here. What kind of form this is here? Quadratic form. What kind of form this is?
Completely square.
Y'all keep saying that over and over because CXC will hit all your question and they would not put this and they will just ask it to complete the square and all it will be lost. This is completing the square form, right? So let me go. So A is equal to, B is equal to, C is equal to, come on, man. H is equal to B over 2A. K is equal to 4AC minus B squared over 4A. Substitution right now, right? Straight substitution. So there you go. So H will be equal to negative 5 over 2 by 3, which will be negative 5 over 6. K will be equal to 4 by 3 by 1 minus negative 5 squared all over 4 by 3. K is equal to, what do we get when we got it up?
I got negative 13.
Negative 13 over 12, which can be written as a mixed number to be negative 1 and 112. So therefore, if you stop here, you would not get your full marks. Therefore, A open bracket x plus h squared plus k is equal to 3 open brackets x plus plus negative 5 over 6, which could thus be minus 5 over 6 squared.
Take away between a little smaller.
1 over 1 and 1 over 12, right? Proper thing. The next part of the question is saying hence or otherwise determine the minimum value of f of x, right? Minimum value of the quadratic and the value of x, so which f of x is a minimum. So this question is basically asking us for the minimum value, right? And I gave you all a note above where I said that the value of x for which f of x is a minimum is the axis of symmetry. So they are asking you for the minimum value and they are also asking us for the axis of symmetry. So there we go. Minimum value is the value of k proper. So this will be negative 1 and 112. Axis of symmetry is given by x is equal to negative what? H. Right? So this is simply x is equal to negative of negative 5 over 6, right? Because remember, h was negative 5 over 6. So x will be equal to 5 over 6. Everybody get there, my children? Right? That's all they ask us for in that part. Compose yourself, Christian Hart. Let me go. Solve the equation 3x squared minus 5x plus 1 is equal to 0. Expressing your answer correct to 2 decimal places, right? So this whole thing, I'm trying to get all it to understand what's going on as opposed to just knowing what to do, right? So if I ask you to solve this quadratic, I'm basically asking you for what? I'm asking you for the roots of your quadratic, right? Because when you solve this equation, you would find 2 values for x. So I'm letting you all know straight up here, the quadratic factorization cannot work, right? Quadratic factorization cannot work. So let me go. What A is equal to? B is equal to? And C is equal to? So we are going to use the quadratic formula. So x will be equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So x will be equal to negative of negative 5 plus or minus the square root of b, which is negative 5 squared minus 4 by 3 by 1 all over 2a. Well, A is 3. Let me put in A. A is 3. So 2 by 3. That is the first thing we're working out. We're working out what is under the square root, right? So we can't say yeah, negative and a negative is a. So that's right, 5, right? Plus or minus the square root of what? We're getting underneath here.
13.
13, right? All over 2 3s are 6. So we branch it off now, right? So we branch it off. Always have faith in yourself, brother. Never doubt yourself. X is equal to 5 plus the square root of 13 all over 6. And this side will be x is equal to 5 minus the square root of 13 all over 6. X will be equal to what on the left? So there you go. X is equal to, I remember I told you I'll put this in brackets before you multiply. Before you divide, right? So again, when you work out here, the top.
So my table are all bad right now.
Give me the final answer. 1 point?
43.
1.43, and on this side you're getting
2-3.
0.23. I thought it was same 43, so 0.23.
So top I get 8.605555.
Now I don't want to know that. So this question is a question that is slightly different to what we were doing all along, right? But I still want you all to lock in, right? So copy and complete the table below for the function y is equal to 20 over x squared, right? Y is equal to 20 over x squared is actually a quadratic function, right? Okay? It's just written a little differently. So this is a quadratic here. And they said for 2 less than or equal to x less than or equal to 7. This simply means that I'm talking about all the x values between 2. So less than or equal to means that we are starting at 2 and we are ending at 7. All right? So we talk about 2, 3, 4, 5, 6, 7. Right? So I'm going to substitute each one of these values into the quadratic function, right, to get the corresponding value of y.
Right.
Are you seeing it?
Yeah.
All these bad boys supposed to go in here to get the y's, right? But they gave us 3 values of y's already. So the only ones we need to work out would be the ones that are missing. So let's go. Docs, compose yourself. We're looking at the first column. What is the value of x for the first column? 2. Right? What is the equation or the function that they give us above there? Y is equal to? Compose yourself. And x is equal to 2. Huh? So what we're doing with the x that is underneath here, we're replacing it with what? Come on, man. Come on, let's go. Right? So this will be, instead of x squared, it will be 2 squared. So 20 divided by 4 would give me, look at, watch it. What to do again, right? So the other value that has a missing y value would be when x is 5, right? You are using the same function. Y is equal to 20 over, let me just put in one time now, 5 squared, all right? So y will be equal to 20 divided by 25, which will be what?
0.8.
Put in 0.8 here. Last situation here. When x is equal to, come on, man. Y is equal to 20 over 7 to the power of 2. Okay, remember it's x squared. Replace it x with 7, right? So this will be y is equal to 20 divided by 49, which will give me 0.4.
Like food, like.
Food buy. Come on, man. What are the coordinates of x and y in the first column? It's 2 comma what?
2,5.
What are the coordinates for the second column?
3,2.2.
2.2. That was 0.2. 2.2.
Okay, that's fine.
Next. Next is what?
4,1.3.
Next.
5,0.8.
And the last one, I think this is the last one.
6,0.8.
Now say that one next one. 7.
That was 7? Oh, this is 0.6, and then that was 7. And then 7, comma 0. Right. Okay, so we have some coordinates we have to plot here, right? So this first one was what? I just put in the coordinates of the point. You don't need to do this, right? This one was 2, comma 5. Everybody good there? What this one was? This one was 3, comma 2.2. What the next one will be? 4, comma what? Give it quick. 4, comma 1.3. So you're going 1.1, 1.2, 1.3. Right? So this will be 4, comma 1.3. Hit me the next one. 5, comma what?
5,0.8.
0.8. So 0.5 would be here. This will be 5 here, right? 5 is here. So you're going 0.5 is in the middle here, in between 0 and 1. So 0.8, this will be 0.5, 0.6, 0.7, 0.8 would be here, right? So let's go. This will be 0.8, 5, comma 0.8. Next one, 6, comma what?
6,0.6.
Right, so 0.5 is here, 0.6 would be here. So this will be 6, comma 0.6. And my last point would be 7, comma.
7,0.4.
So 0.5 here, so 0.4 would be here. Now I am labeling my coordinates, but you don't need to do that, right? I'm just doing it so you all see. So I'm going to draw a smooth flowing curve because it is a quadratic. A quadratic would be a curve, right? So this curve here will be y is equal to 20 over x squared. Everybody get there? That's my curve. It's 10:55. This will be the last question we do now, right? Okay, I just drew it's supposed to be a smooth flowing curve going through all the coordinates, and then you label the curve at the end. Right? Everybody good there? So the second part was to actually draw a smooth curve through the points, right? So boom, bang, boom, bang. Using your graph, estimate the value of y when x is 4.5. So we're going back here. X is 4.5 would be here. Everybody agrees? So let's see if we could line up that now. So we come in here, 4.5, boom, bang, bang. And then we come in over here now. So on your graph, what looking like, boy? Mine's looking like it could very well be 1, you know. Mine's looking like it could be 1, yeah. All again 1?
Yeah.
Right. So I'm getting 1, right? So let me go here and put that in now, right? So, right? So y will be equal to 1. Everybody good there? Y will be equal to 1. Find the value of x when y is 3.5. Let's go. So find the value of x when y is 3.5. Look, 3.5 is in the middle here. Let's work. 3.5, we come in here, so bow. Tell me all again. Mine's looking like 2.5. I think mine's looking like 2.5.
I get 2.6. I get 2.56.
2.6, that's okay. Go with what you get on yours, right? I get 2.4. I get 2.4.
2.5.
2.5, go with what you have. Write what you have, right? Don't write what I put in here. X will be equal to 2.4 on my drawing, right? Okay? F of x is the same as y. So if I put y is equal to x squared minus 2x minus 3, it comes like I'm saying f of x is equal to this, right? What kind of function this is again here, guys? Quadratic, right? Stick that on your brain. This is a quadratic, right? Now they said that this function is defined by the domain. All right, brother? Yeah, all the best one, right? So the function y equals to x squared minus 2x minus 3 is defined by domain -2 less than or equal to x less than or equal to 4. So this simply means that for all my x values, I'm starting at -2 and I'm going straight to 4. Okay? So you'll see all the values here: -2, -1, 0, 1, 2, 3, 4. Everybody good there? So domain. For those who don't know what a domain is, My domain would be my set of x values, right? My domain would be my x values, right? All right, that's a little better. My domain would be my x values, right? You all know what your y values are? Anybody knows? You have your domain and your range, right? Your range would be your y values. So the table shows corresponding values of y for the 5 selected values of x, right? So just like this morning, straight off the back, you have your quadratic function above, you have your values of x, you need to find the values of y. So what we're doing, you see all these bad boys here? You substitute them into that. You see it? You see it here? Let's see it here? Boom, bang. Everybody had to go there. Everybody going into this function, right? Okay, so they already gave us these 1, 2, 3, 4. We just have to find 3. So let us work, right? So we start with the first column, bro. What is the value of x to the first column? When x is equal to -2, y is equal to what? Look at it right above there. Y is equal to what? Huh? Just don't give me what y is. What y is here? X squared minus 2x minus 3, right? That is the quadratic function that is defined as y, right? So that's y. Okay, everybody good there? So let me work. What do we replace x with? Yeah, compose all yourself. What do you replace with x with? You replace x with -2 to the second power minus 2 by, what is x? Minus 3. This is not no baby show. Punching that on a calculator. Give me the value of y, please. Somebody. 5, straight off the back. That's what we're talking about. We ain't come here to play. Right? So, our next column that has a missing value for y. Right? What will be the value of x there? When x is equal to? So, let me just do the work in here straight. Right? So, y will be equal to 1 squared minus 2 by 1 minus 3. Y will be equal to minus 4. Put him in -4. Last one here. So last value of y that I need to find would be when x is equal to 3. When x is equal to 3. It's 3 or -3? It's 3, right? So y will be equal to 3 squared minus 2 by 3 minus what was the last number? 5? 3. Yeah. So y will be equal to what? 0. Proper. So that 0 coming here. Right? So the next part is using a scale of 1 centimeter to 1 unit on the x-axis and y-axis. Plot the graph for this quadratic. Come in. Quadratic function. Come in. Y is equal to x squared minus 2x minus 3. Everybody good there? I thought you go.
Yeah.
So we're going to plot the points for the quadratic curve and then draw the graph. Somebody hit me the coordinates. What's the first coordinate? Proper. Next. Next.
0, -3.
1,
-4. 2, -3. 0, 3, 0, and 4, 5.
right? So where did I get these coordinates from? I got these coordinates from the table that I was given above, right? So we have a quadratic function. We had our domain, which will be our x values. We found our corresponding y values. We established our coordinates at the bottom here, and we are going to plot our graph, right? Plot the points on the graph and draw a smooth flowing curve through it, right? So the part 2 is to draw the smooth flowing curve, right? So the first part is to plot the points. Second part is to draw the graph itself, right? So 1 centimeter to 1 unit on both axes. Hit my first coordinate there, please. All right, to start a plot now. Coordinate number 1. -2 on the x-axis, 5 on the y. Where do these 2 points meet? Look at it here. -2 on the x is down here. All right, so you're tracking it up till you reach the line that comes across from -5, right? So that coordinate would be right here. So let's plot that point. That's my first point here. And we'll go. Right, so next coordinate, please. What's the next coordinate? Negative
-1 and 0.
and 0. So that's on this axis itself, right? -1 on the x, 0 on the y means that we are on the axis, right? Next coordinate.
0 and 3.
0, comma, -3. We here, bang. Next.
1 and -4.
1 and -4. So 1 on the x is right here. So look at it. 1 on the x is right here. And -4 is here. So where do the 2 points meet? 1 and -4. Right here. So we come in, bang, 1, comma, -4. Next one.
2 and -3.
2 and -3. So we have 2 and -3. So we start to come back up there already. Boom. Next one.
3 and 0.
3 and 0. And then 4 and what? 4 and 5?
5.
That's tough curve, boy. Y is equal to. Alright. So we have y. Hey, that took 10. Hold on. Alright. So y is equal to x squared minus 2x minus 3. Right? That will be the quadratic that defines this curve, right? You plot your points, you put a smooth flowing curve through our points. Right? So let me move. Using information from your graph, complete each of the following statements, right? So the values of x for which x squared minus 2x minus 3 is equal to 0, right? This simply means when my quadratic curve is cutting through the x-axis, right? What are the coordinates of the two, well, the x coordinates of the 2 points where our curve is cutting through our x-axis? Look at right here. -1 and 3, right? For those who not seen it, let me highlight it right above here, right? We're talking about these two coordinates, -1 and 3. That is where my curve is cutting through my x-axis. Oh my gosh, the minimum value of a quadratic, right? Watch the keyword here. Eden, watch the keyword there. Minimum value, right? What is the minimum value? The minimum value is the value of what? K. Very good. Right? It's the value of K. Right? Now, the value of K is actually given by the minimum point. Right? You all know what the minimum point is? It will be -h comma K. Right? And what -h comma K would be here? This will be equal to h is actually going to be 1. So leaving it as 1, it simply means -h is equal to 1. Right? So leave it as 1, comma, what is K? K would be -4. So therefore, the minimum value of my quadratic y is equal to x squared minus 2x minus 3 would be -4. We winning or we losing? So the equation of the line of symmetry of the graph, well, the quadratic graph, right, is what? They are basically asking us for our axis of symmetry, right? So your axis of symmetry is actually going to be given by x is equal to -h, but we don't know -h is what? 1. -h is 1. That is the value here. So the equation of the axis of symmetry is basically the equation of a line that goes from top to bottom and passes through the value h. Well, -h in this case, right? So this will be x is equal to 1. Everybody good there? Right? So this would be x is equal to 1. Proper thing. I want the values of x for which the same quadratic we're dealing with above, right, is equal to a linear. Right? So we have a quadratic curve and a linear equation here, which is actually going to be a straight line. So the values of x for which the quadratic is equal to the linear would be the values of x where the line cuts the curve, right? So I actually need to draw that straight line, right? So I need to draw the line y is equal to negative x plus 3, right? And if I give you the equation of a linear line, and I ask you to draw that, I could do two cases. I could do when x is 0, when y is 0, get the coordinates of 2 points on the line, and let's draw a line going through it, right? So let's do that, please. We need to get the coordinates of 2 points on the line. So let me go. So we need to draw this line. So that means that we need to, I'm going to read out this note because I didn't read it for the recording, right? To draw a straight line given an equation, we find the coordinates of 2 points, namely when x is 0 and when y is 0, and draw a straight line through them, right? So I'm going to do on this side when x is equal to 0 and on the other side when y is equal to 0. So when x is equal to 0, what y would be? Y would be equal to, there's no such thing as negative 0. So let's be 0 plus 3. Y will be equal to 3. So what are the coordinates of this point here? 0, comma 3, proper thing. Right? Let me go on this side now. Y is 0. So what am I replacing y with here? I'm replacing y with 0. 0 is equal to negative x plus 3. I can just carry the x on this side because x is negative. When it goes to the left, it becomes positive. So x will be equal to the same 3 here? Yeah. X is equal to 3 because x plus 0 would simply be x, right? So what are the coordinates of this point, my children? 3, comma 0. Understand the difference. 0, comma 3, 3, comma 0. We winning, right? We winning. Okay? So we're going to plot these 2 points on my graph above, establish the 2 points of intersection, and that will be how we will get our x values, right? Because that's what the question asks. The question asks for the values of x, right? For which the quadratic is equal to the linear, right? Okay? Everybody good there? So let's find our two values. Let's plot the 2 points now. I'm going to do it right here. I won't go back on my $23 up. All right, so let me go. So 0, what was the first one? 0, comma 3 would be right here. No, 0 on the x, 3 on the y will be here. I'll put this one in a different color. Let me go green. All right, 0, comma 3 would be here. And then 3, comma 0 would be here. So we draw a straight line through. Make sure you line up the 2 points, draw your straight line, right? Okay? So I bring this down a little bit. Are we looking there? Kyle, are we looking there?
Good, sir.
Now we talk about how our mock exams over, eh? We need to label this, right? This will be the line y is equal to negative x plus 3, right? So where the line and the curve intersect would be the x values for when the quadratic is equal to the linear, right? So let me just give you all a clear visual here, right? So you see these two things over here, these 2 points over here, these will be the values or the coordinates, right? The coordinates of the points of intersection, right? So it's basically when the quadratic, which is x squared minus 2x minus 3, is equal to negative x plus 3, right? Those will be the coordinates when the quadratic is equal to the line, right? So the values of x would be, coming down here, boom, negative 2 and 3. Well, we on 3 itself, right? We on 3. Okay? So that will be the x values for which the quadratic is equal to the linear. So negative 2 and 3. How we feel it now? Analyze it by meanwhile. They said the diagram below shows a sketch of the quadratic function y is equal to x squared plus bx plus c. They also said that negative 2 is less than or equal to x, which is less than or equal to 6. This simply means that my x values start at negative 2 and moves to 6, right? So your first x value here, which would probably be the coordinates of this point here, would be like negative 2 here, and the last one up here would be 6. Everybody clear there? Right, so let's see what the question itself is asking, right? Scrolling down. So the first thing they ask us for down here would be the roots. I've seen it right here. State the roots of the equation x squared plus bx plus c, which is equal to 0, right? What are the roots of an equation? Dog food. I'm still going to put our definition here, right? So the roots, write it down, note. The roots are the x-intercepts. Clear as day here, right? What's the name again? What's the name? Sapphire. What are the x-intercepts or the values of x where the curve is cutting through the x-axis? You see that clear as day then? You not seeing it clear? So the roots of the quadratic equation is simply the values of x where the curve is cutting through the x-axis. So clear as day, my roots would be x is equal to negative 1 and x is equal to 5, right? Not negative 5. Are we clear? So for the function y is equal to x squared plus bx plus c, determine the value of c. The value of c is my y-intercept, right? Which is basically where the curve is cutting the y-axis. So therefore, c is equal to, in this question, c would be negative 5, because that is where my curve is cutting through my y-axis, right? So c is equal to negative 5. Right, we got there, Sapphire? So they proceeded to say, show that b is equal to negative 4, right? If I were to rewrite the function, putting in c, the function would be y is equal to x squared plus bx plus negative 5, which would just be minus 5, right? If I could identify, in order to find the value of b, what I can do is identify one coordinate, well, the coordinates of one point on the curve, right? Use that as my x value, as my y value, substitute it into this quadratic, and the only thing that would be unknown would be b, right? So identify the coordinates of any one point on this curve, right? I go with this one here, since it has no negative in it, right? What are the coordinates of this point? Not the x-intercept, I asked the coordinates. What would be the coordinates? 5, 0. So what is the value of x here, my children? X would be, and y would be. So I can proceed to say when x is equal to 5 and y is equal to 0, which is a clear coordinate. Now you could have used negative 1 comma 0. You could have used 0 comma negative 5, and you would get the same thing. All right? So let me work. We plug in a scene. So y is 0. So what am I replacing y with? 0 is equal to, what am I replacing x with? 5. So it'll be 5 squared plus b by 5 minus 5, right? So lock in, 0 would be equal to 25 plus 5b minus 5, right? I simply b multiplied by 5 is the same as 5b, right, Aiden? b multiplied by 5 is the same as 5b, right? So 25, I could do this side here. 25 minus 5 will give me 20. Let me think that 20 on the other side one time, right? Okay? I'm going to write that. I see some people don't understand what I'm saying. This will be 20 plus 5b. They're going to fling this 20 here one time. The opposite of plus is to minus. So this will be 0 minus 20, which will give me negative 20 on the left-hand side, right? So this would be negative 20 is equal to 5b. What do I do now to find the value of b? I'm going to carry this 5 here and do what? Divide. So let me do it right here, right? So 20, negative 20 divided by 5 would be equal to b, right? Negative 20 divided by 5 will give me negative 4 is equal to b. And I can put a little box to indicate that it was shown. Are we clear here, my? So state the coordinates of the minimum point on the graph for the function y is equal to x squared plus bx plus c. Now, we just found b. B was equal to negative 4. We found c. C was equal to, and we know what a is. What a is from this function here? 1. Dog food. The coordinates of my minimum point are given by what? Coordinates of the min point is given by negative h comma. Come on. What we know h is equal to? Come on. K is equal to? Come on, man. I was supposed to belt out that. So h would be equal to b, which is negative 4 over 2 by 1, which will give me what? H is equal to negative 2. K would be equal to 4 by 1 by negative 5 minus b, which is negative 4 squared all over 4 by a, which is 1. When we work out the numerator here, what do we get for the numerator? Negative 36. When we work out the numerator divided by 4, k would be equal to negative 9, right? So we have h, we have k. So therefore, negative h comma k, which are the coordinates of my minimum point, would be negative of negative 2. You all realize that? Comma negative 9, which would be 2 comma negative 9, because a negative and a negative would be a positive, right? Proper thing. So we on to number 10, I believe it was, right? Yes, number 10. So when I get a question, right? Sometimes I don't even watch what the question asks. I analyze the facts, right? What are the x-intercepts here? Let me zoom in properly. Negative, well, 1 and negative 3. That's a fact, right? What is the y-intercept? Negative 3. Fact, right? That's a fact. What are the coordinates of the minimum point? Negative 1 comma 4. Negative 4. Fact. That is a fact, right? So we have all these facts and we're going to roll into the question now, right? Okay? I don't like this question one. The scale, using the graph above, determine the scale used on the x-axis. Come on, man, CXC. Better than that. What's the scale used on the x-axis?
1 unit to 2 centimeters.
1 unit, right? Yeah, 2 centimeters to 1 unit. Meaning that each 1 unit we put, it's 2 centimeters apart. The distance from here to here is 2 centimeters apart on the x-axis. Just a curiosity, what is the scale on the y-axis? 1 centimeter to 1 unit on the y-axis, right? So let's go. The value of y for which x is equal to negative 1.5. So we're going to when x is negative 1.5, right? Negative 1.5 is negative 1.5. That's it. Everybody agrees? So I'm looking for the value of x. So I'm going to come down, boom, bang, to meet the curve. Bang. And we're going to cross. So from here to here is going to be 1, right? So if it is 5 spaces, I'm splitting that 1 in 5, right? So it's like 0.1 is like 0.10, right? So every 0.2 would be one stroke, right? One small stroke. So this will be 3.2, 3.4, 3.6, and this will be 3.8. 3.8. Okay, that's the value of y when x is equal to negative 1.5, right? Let's go. So the value of y here, y will simply be equal to negative is negative 3.8. I just put 3.8. It's supposed to be negative 3.8. Everybody good there? We winning. We definitely, which are our x-intercepts, right? So our x-intercepts, which is what they are asking for in part 3, the values of x for which y is equal to 0. Y is equal to 0 on the x-axis, right? So my x-intercepts will be x is equal to 1 and x is equal to negative 3. So let's go. X is equal to 1 and x is equal to negative 3. Above, I don't know if you all remember when I said your x values would be your domain. I said it above. And then I said your y values would be your range. Right? Write that down for me. That's a little reminder. Note. Wait. Note, right? So my x values would be my range. Right? My y values would be my I write it wrong. Yeah, I write it wrong. Domain, and this is my range. Right? Domain x values, right? So I want to give you all a visual on this. When I'm talking about the domain, I'm talking about all the values that could possibly be a point on my curve. So those x values would be like starting from here, boom, right? This point here, and then ending here. You all seen it? So my domain would be from negative 4 less than or equal to x less than or equal to 2. Meaning that I have an x value on that side, right? I could even extend this line coming straight down, right? Are there any x values lined up with anything else on that curve? All my x values are in between those points. You all seen it? Watch it. Draw a next line coming down here. All my x values are in between these two coordinates here, which would be negative 4 and 2. I have no x values outside of that. My curve did not go beyond this point here. Right? Everybody clear there? That's my domain. Let me deal with the range now. Right? What's the lowest value that y could be? Hit me. Negative 4, boy. Watch that. Hey, Ollie, watch that. We winning now. Negative 4 is the lowest value that y could be. Watch it there. Jibril, you seen any other value y could be under that? Nope. And what is the highest value that y could be? Proper, boy. Proper. It had no value of y beyond this point here. The curve ain't go nowhere beyond this point. Watch it. I surely never understand that in all your life. And all your understanding that today. Right? My y value have no part on that curve beyond that point. Right? So my y value starts at negative 4 because you always put the lesser number first. And it goes straight up to 5. Cool? So that's how we write in our range underneath here, right? Right? So we're giving it in this form. So what was the lowest value of y? It was negative. So this is my range. My range would be negative 4 less than or equal to y less than or equal to, what was the highest one? 5. You ever understand that domain and range right before? You understand it now. Right? Your range would have been your domain would have been, they didn't ask you for the domain here, but your domain was negative 4 less than or equal to x less than or equal to 2. Proper. Right? So June 2024, number 8, basic foundation functions, right? They give you a linear expression that defines f of x, and they give you a quadratic expression that defines g of x, right? They want you to determine the value of g of 2. So if I want g of 2, it means wherever I see x here, I am putting 2. So this will be 5 minus 2 squared. 2 2s are 4. 5 minus 4 would give me 1. Right? The next part of the question is they want me to find f negative 1 of 3, which is the inverse of f of x. You're putting 3 into that inverse, right? So what do I need to do here? I need to find f negative 1 of x first. Everybody good there? Okay? So to find the inverse of any function, I would first need to write down the original function, right? So I'm going to write f of x is going to be equal to 2x minus 1 all over 3, right? Okay? So I'm going to express it. Instead of putting f of x, I'm going to put y. Y is equal to 2x minus 1 all over 3, right? So at this point, I'm going to replace, or I'm going to swap x and y, right? So let's swap x and y, meaning that I'm putting x where y is, and I'm putting y where x is. I don't know what I need to do now. I need to make back y the subject, right? Okay, so what's the first thing I'm moving? This 3 that is in the denominator position is holding everything in the numerator position captive. So you have to set the captives free. So you have to move that 3 first. You cannot move that 1 first, which is a common mistake. Children love to take that 1 and fling it on the next side first, right? So you're moving the 3 first. When I move 3 here, what do I do with it? It's being divided on the right here, multiply. So this will be 3x is equal to 2y minus 1. Right? What is the next thing I'm moving, right? That 2 locking on that y, you can't move that, right? You have to move the 1 next. When I carry 1 here, what do I do with it? Add it proper, right? So this will be 3x plus 1 is equal to 2y. I need to make y the subject, meaning that I need y on one side of the equal side by itself. So the last thing I'm going to move here would be the 2. When I move the 2 to the left, what do I do with it? All over 2 is equal to y. My last step is to express f negative 1 of x as the answer I got here for y, right? So this will be equal to 3x plus 1 all over 2. That is the inverse of my function f of x. Next, I need to put 3 into that inverse of the function. The question wanted me to find f negative 1 of 3. So f negative 1 of 3, what do I replace x here with? I replace x with 3 3s are 9 plus 1 is 10 divided by 2 would give me talk done. Talk done. So derive an expression in its simplest form. Now I said the word simplest, so you need to break it right down, right? For f g of x, this is my composite function, right? Okay, a composite function is a function into a function, right? Which function goes into which? The second into the first. Second function into the first. Right? So G goes into F. Right? So I want to do this thing as structured as possible, right? So f of x was, f of x was 2x over 3, and g of x was minus x squared, right? So follow, if I want to find, watch it here good, guys. If I want to find f g of x, is basically I want to put g of x, which is 5 minus x squared, into f of x. Right, Eden? Eden, watch it there. You see this bad boy here? You see that? That taking the place of x here. Teleporting. Boop, 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 boop. Right? So watch how you go and look, right? So f g of x will be equal to 2 open brackets 5 minus x squared close bracket. You still have to put the minus 1 all over 3. So if they want us to write this in its simplest form, we need to get rid of the, take the number in front of the brackets and you multiply it by every single thing within, right? So this will be equal to 2 by 5 will give me 10 minus 2 by negative x squared will give me 2x squared. You still have to put back the people minus 1 all over 3. Everybody good there? So negative 2x squared, and then you could have 10 minus 1 will give me positive 9, right? 10 minus 1 is positive 9 or plus 9, right? All over 3, right? Now they said in its simplest form, we could actually write this simpler, right? You know what mad people let's do? Mad people come and say 3 into 9 is 3. And they put the answer as negative 2x plus 3 and they'll get a big x, right? This denominator here of 3 must be divided by both terms above, right, Desha? This goes into this goes into this. So this will be equal to, let me call it space here. This will be equal to negative 2 over 3 x squared minus 9 over 3. Which will be, not minus, plus, sorry, which will be negative 2 over 3 x to the second power plus 3. This is my composite function in its simplest form, right? So sketch the graph of the function g of x in the space provided, right? G of x was equal to 5 minus x squared, right? On your sketch, indicate the maximum or minimum point and the roots of the function, right? The roots will be the values of x where the curve cuts the x-axis. I go to ball y-axis, yes, x-axis, right? So something we know about when our curve is cutting the x-axis is the value of y will be what? Y is equal to, what is it? 0. When a curve is cutting the, when a curve cutting your x-axis, what's the value of y here? Here in the middle here, 0. It would be 0, right? So when y is equal to 0, let's find the corresponding values of x, right? So what you say? Y is, you remember, g of x or f of x or anything x function. A function is basically y, right? So I'm going to rewrite this as y is equal to 5 minus x squared, right? But y is equal to 0. So what do I replace y here with? I replace y with 0. 0 is equal to 5 minus x squared. I'm going to carry this x squared here. And that minus x squared will now become positive x squared, right? Is equal to 5, right? Now, if I want to find the values of x, I need to find the square root of 5, right? You need to find the opposite of squared on the right, which is 5. So x will be equal to the square root of 5, right? And the thing about this, right? This is actually going to be plus or minus the square root of 5. So we'll still have two answers here, right? So let's branch off at this point, right? So you only do this when you're doing quadratics, right? So this will be x is equal to positive square root of 5, and then x will be equal to negative square root of 5. What is the square root of 5? 2.24. So I go 2.2. 2.2, positive 2.2, and negative 2.2. All right? So they want us to show the roots. So these will be my roots, right? So roots would be this and this, right? Make sure you have it. Disappoint me, eh? The maximum or minimum point is given by what? The coordinates of the maximum or minimum point is given by music to my ears, right? Negative h comma k. So here I want to do, you see this quadratic? I'm going to rewrite it as, what's the order? I'm going to put y is equal to, I'm going to put the negative x squared first, right? And then I'm going to put plus 5 second. Lock in, eh? Lock in, right? What is the number that is understood in front x squared there? Negative 1. So A will be equal to negative 1. What B is equal to? You seen any B here? 0. There's nothing x. And C would be equal to 5. Right? What is the value of H? H is what? Formula, belt it out.
You got to wait.
And what is K?
4ac minus b squared divided by 4a.
Right? Proper thing. Right? Let's work. So H will be equal to B is 0 over 2 by negative 1. 0 divided by anything would give me 0. So H is equal to 0 and K. I need to parallel partition here. Boom, bang, bang. Alright. K would be equal to 4 by negative 1 by 5 minus 0 squared, right? All over 4 by negative 1, right? What would my numerator be here? It would be negative 20 minus 0, which will be negative 20, divided by 4 by negative 1 will give me negative 4.
Negative 4.
So K would be equal to 5, positive 5, right? Positive 5. So I'm writing it right here. So therefore, negative h comma k, well, it had no negative 0, so that's be 0 comma 5 would be my, is this a maximum or a minimum point, guys? Papayo, Gibral and Zaria, right? So when a is greater than 0, this implies a minimum curve, right? And when A is less than 0, meaning it's a negative, which is here, A is a negative, so this will be a max curve. Mia, you saw that?
Yeah, taking our time though.
Let's go. So we're going to plot the people graph, right? So let me plot the maximum point first. 0 on the x and 5 on the y, right? So that'll be 1, 2, 3, 4, 5. So we on the y-axis. Everybody agrees? Right? That's your maximum point. That's the top of the mountain. Then let me get our x-intercepts or our roots. Here will be 2. Here will be 3. So 2.2 will be the first small stroke here. Everybody agrees? This is 2, right? Okay, this was 5. Then this is negative 2, sorry. Negative 2.2 and then positive 2.2 will be here. Boom. This is right here will be positive 2. So what is that? They said to sketch it, right? So let me go. I'm going to sketch it, which is a rough sketch, right? They're coming up. Bling, 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 bling. Blank. Wait. I make it. Label your curve, eh? This curve will be y is equal to 5 minus x squared, right? You could put g of x is equal to 5 minus x squared. Doesn't matter, right? This here is my quadratic curve where I'm showing the maximum point, right? This is my max point up here, right? So this is the max point. And these are my roots. Talk to Mr. Fire. 8. Right, part B. The graph below shows a quadratic function. Okay, thank you. You realize this curve is not cut through the x-axis, so there are no x-intercepts, right? But we seen one fact here. What's the one fact? Like, one clear fact is that the y-intercept is what? 1. That's the only clear fact, because I still kind of not seen the minimum point clearly here, right? So let me see what they're asking. On the grid above, draw the tangent to the curve at x is equal to 1, right? So the tangent to the curve where x is equal to 1. So x is 1 here. So if I want a tangent to the curve when x is 1, right? That means we need a straight line touching this curve at one point there. Okay, so watch it. It could look like this. All right. No, look, x is equal to 1 here. Them on kicks, sir. That one, look at that one hiding there. You all see that? Let me highlight it there. Look, 1 here, my children. Look, 1.
Yeah.
So that will be here. So a tangent to a curve is a straight line that touches the curve at one point. For part 1, that one point would be when x is 1. So it's going to be a straight line touching the curve at only one point. So you see now it more or less touching the curve at just one point there. That is my tangent. Then they said use the tangent drawn to estimate the gradient of the curve at x is equal to 1. So if I want the gradient of the curve at x is equal to 1, I have the coordinates of this point. What will be the coordinates of this point? What is the value on the x-axis? Comma 3. So we have one coordinate on that line, right? And then let's just locate another coordinate. It's actually, yes, pass it through here. So this will be what on the x? What's the value on the x-axis? 0, comma, -2. So in order to find the gradient here, we need to work that. If all you don't know what the formula for gradient of a line is, I go flip out here. Y2 take away. That's foundation, right? So let me just again baby, let's still that's baby earlier. X1, Y1, X2, Y2, right? Those are these coordinates here. So this will be equal to Y2, we'll call that 3 minus Y1, we'll call that -2 all over X2, which is 1, minus X1, which is 0, right? So what is the gradient of my line here? This will be what? 5 over 1, which will be 5. 5 divided by 1 is 5. Okay? That's the gradient of my line. Are we looking here? So for part 3, we know that our y-intercept is -2 because that's where our tangent is cutting through the y-axis, right? And we just calculated that our gradient is 5. So therefore, send this down. So therefore, y will be equal to m, which is 5x, plus c, which will be plus -2. That will give us -2. This is the equation of the tangent to the curve, right? So January 2024, question 8 part B, we had to write a quadratic in completing the square form, right? This is completing the square, right, form. So we go in. A is equal to 4 because this quadratic is of the form ax squared plus bx plus c, right? A is equal to 4, B is equal to -24, C is equal to 31, right? Everybody good there? H is equal to B over 2A, K is equal to 4AC minus B squared over 4A. H should be equal to -24 over 2 by 4. 2 4s are what? 8? 8 minus 3, right? 8 into 24 is minus 3. K would be equal to 4 by 4 by 31 minus -24 squared all over 4 by 4. K would be equal to, what's the numerator? 1072 positive. Nah, something looking wrong here. So -80 over 16, and the answer is -5. That is K. So the question wasn't to find H and find K alone. It was to write a quadratic in completing the square form, right? This is what we do last week. You good here? Right? So we're writing it in. Talk to my bro. Okay, so we found the value of H. We found the value of K. So, as I was saying before, the question did not ask us to find h and find k. It gave us a quadratic. They want us to write this quadratic in completing the square form. All right? So, let me go. I'm going to write this. Let me send this down. Boom, boom, bang. So, therefore, A open bracket x plus h close bracket squared plus k would be equal to, what was A? A was 4? 4 open bracket x plus negative 3 will be x minus 3 squared plus negative 5, which will be minus 5. This here is completing the square form. On the axis below, sketch the graph of 4x squared minus 24x plus 31, indicating the coordinates of the maximum or minimum point and the y-intercept, right? So we're looking for the maximum or minimum point and the y-intercept. Call it this appointment here. The maximum minimum point is given by what? Negative h, comma, right? And this will be what? This is my, is it a max or a min point? It is a min. Why it is a min?
A is equals to 4.
A is equal to 4, which is greater than 0, right? So negative h comma k would be what? Negative
3.
of negative 3 comma negative 5, which will be 3 comma negative 5. This will be, these coordinates here would be the coordinates of my minimum point. We also need to show on our sketch the y-intercept. So my y-intercept will be the value of
31.
C.
Well, C.
Very good. All right. So y-intercept would be C is equal to 31. All right. Look, see here. Boom. Okay. Talk to my Aiden. All right. So there we go. That's all they want us to show. Don't try to be no hero and show nothing else, right? So we go in. 3 on my x-axis will be somewhere here. This is just a sketch, so it's just, something like a gauge, right? Negative 5 on my y-axis would be somewhere quite down here. Negative 5, right? Okay? I think I want to put 3 a little closer. All right? 3, positive 3 will be like somewhere here. Right? So the coordinates of my minimum point would give me the minimum point at around here. Are looking good there? That will be my minimum point. And my y-intercept would be when C is 31, quite up here. When this is my y-intercept, so this is a very sharp curve. All right? So we coming down. Whoop. I miss yes. And I think we go fix that. What are we doing? We doing so bow, we move the point, we just move down the point, that's all. Bang. So you have your minimum point and you have your y-intercept. You winning or we losing? Have to win, bro.
Negative h.
Proper. Right? So your axis of symmetry would be x is equal to negative h, right? This will always be an axis of symmetry. X is equal to negative h. So this will be x is equal to, was it negative of negative 3? And h is negative 3. So a negative and a negative would be a. So my axis of symmetry would be x is equal to positive 3. Your axis of symmetry would simply be a line that runs from top to bottom. It runs vertically and it passes through the value of x for that represents the minimum point. Hey, but the stroke off here, boy. Put the stroke a little more so. Right, so boom. That is where 3 is, right? So the equation of this axis of symmetry would be x is equal to 3. Right? Axis of symmetry is a straight line that cuts my curve into 2 equal parts. Alright, so the functions f and g are defined as follows, right? F such that x maps onto x squared plus 3. Point to note here, alright? This is simply the same as writing f of x is equal to x squared plus 3. Cool? That's your function for f, right? They also said that x is greater than or equal to 0, meaning that x could never be a negative number for this function, right? Then they said g such that x maps onto 2x plus 2, right? Meaning that g of x is equal to 2x plus 2. Everybody good there? All right? Now, calculate the value of g negative 1. Foundation functions, right? This is like the first thing we do doing functions, right? So g of negative 1 will be equal to 2 multiplied by what? Instead of x here, what do we put? 2 by negative 1 plus 2, which will give me what? 0. 2 by negative 1 will be negative 2. Negative 2 plus 2 would be 0. Everybody good there? Soak that in. This is g of negative 1. Right. So the next part is to write down the expression for the inverse of the function f of x. So it's f negative 1 of x, right? So what do we start with when we want to write the inverse of a function? We start with the original function first, right? What's the original function? It would be f of x is equal to x squared plus 3, right? So you are going to, instead of writing f of x, you're just going to write it as y is equal to x squared plus 3. At this point in time, you want to interchange what? X and y. So wherever x is, you're going to put y. Wherever y is, you're going to put x. This will be x is equal to y squared plus 3. Everybody good there? Y squared plus 3. Okay? So at this point now, we need to make back, quote unquote, make back y the subject, right? So let's proceed to make back y the subject of the formula here. What's the first thing we move in? When we carry 3 here, what do we do with it? X minus 3 is equal to y squared. Then we need to get rid of the squared. What's the opposite of squared on this side?
Square root.
So to be square root of x minus 3 is equal to y. Everybody good here? So last step here would be therefore f negative 1 of x is equal to what we just found, which is the square root of x minus 3. Alright, Mikhail, talk it again. They want us to derive a simplified expression for g f of x, which is a composite function. For a composite function, you always put the second function into the first. Your second function was f of x. F of x was equal to x squared plus 3. So you're going to put x squared plus 3 in place of x in g of x, right? So you see this whole thing here? This whole thing here is going to take the place of x here. Everybody clear? Alright, so let me work. So this will be equal to 2 open brackets what? What goes into my brackets? Am I here earlier? X squared plus 3. And what you still have to put here? What's still missing? Plus 2. Right? All I know the working on is just you need to practice more, boy. Right? There we go. 2 into this, 2 multiplied by this, and then 2 multiplied by this. Because what's what they put? Simplified. So if you leave it like this, you would not get your full marks, right? So 2 multiplied by x squared will give me 2x squared. And then 2 multiplied by 3 would give me 6 plus, you have to put back in people, plus 2. So this will be equal to 2x squared plus 8. Everybody good there? They said that f g of x is equal to 4x squared plus 8x plus 7, right? They told you what f g of x is here. Then they gave you an equation and asked you to solve the equation. To solve the equation means to find the value of the unknown variable, right? So let's replace f of g with what f of g, well, f g of x is, right? What is f g of x? F g of x would be 4x squared plus is equal to 2 multiplied by what is g f of x? We just found it. Close bracket. And where you still had to put? You had to put back the people. Must put back the people plus 15, right? So if you need to, this is this, right? If you need to solve, you will first need to get rid of the brackets. Let's look, right? So you're going to multiply 2 by 2x and then 2 by 8. So this will be what? This will be 4x squared plus 8x plus 7 is equal to 4x squared plus 16 plus 15. Right? So what we doing? Let me fling this 4x squared here now. And let me add these two things together. And whenever I get fling it here one time too. Everybody agrees? You good there? I'm Keegan.
Yes.
So the better thing to do is to leave the 16 and 15 on the right and carry the 7 to meet the 15 and 16, right? So I'm going to put 4x squared plus 4x when it comes to the left becomes minus 4x squared. So that cancel out the x squareds, right? And I still have plus 8x is equal to 16 plus 15 will be 31 minus 7. Everybody good there? These two things cancel here. You get 0. So this will be 8x. 8x is equal to 31 minus 7 is what? 24. Carry the 8 here. We're doing it. 24 divided by 8. X is equal to 3. Right? So we basically solved this equation they gave us up here. Right? So we're going to plot some points now. So the final part, which is part C, is to plot the graph of the functions f and g, right? F was what? What f of x was? This was the x squared plus 3, and the g of x was what? 2x plus 2. So let me just get some points on the graph and plot them. So let me deal with this first, right? If x are, well, the values of x are greater than 0, it means that we deal with these values of x here coming this way, right? Greater than 0. So let me plug in 1 greater than or equal to 0. So we started at 0. Excellent. So let's start with f of x, right? Okay, so f of x was equal to x squared plus 3. Right, so let me do when x is 0. So f of 0 would be 0 squared plus 3. So this coordinate here would actually be 0 on the x. So this is equal to 3, right? 0 on the x, 3 on the y, right? Boom. Everybody good there? I should put this in a different color. All right, let me do this in red. Boom. Everybody good there? That is 0, comma 3. Then we're gonna do f of 1. We just plot about 3 points, right? 1 squared plus 3 would give me what? 1 squared plus 3 is 4. So this coordinate would be 1 on the x, 4 on the y. So 1, comma 4 would be here. Everybody good there? Then f of 2, when x is 2, would be 2 squared plus 3, which will give me what? 7. Right? So this coordinate would be 2, comma 7. So like plot 2, comma 7. Right? And let's do this now because we don't know what CSEC actually had on their graph, right? So let me just do this now. So you're going from here to here, and then you're going from here to here. Anybody good there? Right? That's the curve for, I'm putting it as y is equal to x squared plus 3. Right? Same thing as f of x is equal to x squared plus 3. Let's plot a few points on g of x now. Right? So g of x was equal to 2x plus 1. Right? Or plus 2. So we're going to find g of 0 first, which will be 2 by 0 plus 2. That's going to give me 2. First coordinate here will be 0 on the x and 2 on the y. So that's starting here, right? Then we're going to do g of 1. That will be equal to 1 square, no, 2 by 1 plus 2, which will give me 4. So this coordinate will be 1, comma 4. 1, comma 4 is the same thing, so it's on the same spot here. Yeah, you could. Yeah, the dot and circle. But we run it here because this look like the only point that they would actually cross. Because look, this G of 2 would be 2 by 2 plus 2, which would
You'll
be
get 6.
6. So that coordinate would be 2 and 6, which is down here. So this looking like there's going to be a straight line moving here, right? So you come in, boom. What is that? 20, I'm on top, boy. Right, let go. Boom, wait. Want that line. Alright. Oh. Wait. Stick with mad, boy. Hi.
Oh my god, that's nothing.
Thing going mad, boy. So this here would be my curve and my line. They touch at one point here, right? They have at this line is a tangent to the curve at the point 1, 4. Right? That's a tangent there. So number 8, what year this was? June 2023, right? Complete the table for the function y is equal to negative x squared plus x plus 7, right? They give you all your x values here. Somebody give me the domain. What we will write that domain as? It will be negative 3 is less than or equal to x is less than or equal to 4. That will be my domain, right? So let me figure out what the range is now. My range will be my what values, Nisi? My range will be my y values, right? Domain would be your x values. Your range would be your y values. So let me work. We first doing when x is equal to negative 3. Look your whole function up here. They're telling you what y is. Y will be equal to, instead of x squared, what do I put? Negative 3 in brackets squared, eh? Because it's negative x squared. X is negative 3, right? Plus negative 3 plus 7, right? So, negative 3 squared is 9. So, this will actually be negative 9 minus 3 plus 7. Which will give me what? What you'll get in here?
Negative 5.
Negative 5.
Negative 5. Proper, right? So let's do when x is equal to what next? What next here, princess? What are we looking at next? When x is equal to negative 1. So let's work. Y will be equal to negative of negative 1 squared plus negative 1 plus 7. So this will be negative of negative 1 squared, which will be positive 1. Guys, you cannot come here and say a negative and a negative is a positive. Eh? You'll get a big X of that. Right? So this will be negative 1 minus 1 plus 7. What you getting here? That'll be positive 5.
Yes, sir.
Yeah, positive 5. So this column here will be positive 5. Let's go. When x is equal to what next here, Keegan? When x is equal to 1. Y will be equal to negative 1 squared plus 1 plus 7. So that'll just be negative 1 plus 1 plus 7 will be 7. Right? That's what you all got here, 7.
7.
And then the last one will be when x is equal to, what's the last one? When x is equal to what? 3, proper. Wait, missed the yes? X is equal to 3. Y will be equal to negative 3 squared plus 3 plus 7, right? So this will be negative 9 plus 3 plus 7, which will give me what? 1?
1.
Yeah, 1. Proper. Alright? Part B. On the grid below, draw the graph of the quadratic function y is equal to negative x squared plus x plus 7 for negative 3 less than or equal to x less than or equal to 4. So we go in. I already wrote down my scale. My scale will be 2 centimeters, so 1 unit on the x-axis, 1 centimeter to 1 unit on the y-axis, right? Hit me the first point there, Yuvraj.
What domain we use? The same domain.
Yeah, well, just give me the code. Give me the first column. Give me the first column. -3 on the x, -5 on the y. So that'll be down here. Boom. Right? Next. -2 comma what? 1. Positive 1. Boom. Wait, what's that? -1 comma 5. 0 comma 1 comma. Ooh, they didn't give us the maximum point there, boy. 2 comma. Yeah, it'll be on the next side. That's mirrored. All right, so it'll be 2, 5, 3, 1, and 4, -5. So that's why I like when Microsoft Word and there's actually get a curve here on that app I paying money for. I don't get no curve. I can't draw no curve.
Yes, sir. I get that.
You get that?
Yeah.
So this is my quadratic curve for the function y is equal to -x squared plus what? X plus 7. Proper. Alright? How we looking then, Mia? So we have to write down the coordinates of the maximum / minimum point. I want to ask you all one thing, right? Looking at the quadratic function there, how would I be able to tell if it's a maximum or a minimum point without even drawing the curve? What do I look at? The value of which one? C?
Negative.
A. I want to say. Somebody said A. A. Right? C is the y-intercept, yes. So A. So write this down now. I want you all to write this. Note. When A is less than 0, this implies that your curve would be a max. When A is greater than 0, this implies that your curve would be a minimum. Right? So you don't even need to draw your curve. You can just look at your quadratic and you'll be able to tell if it's a max or a min. So let's see if we can find these coordinates, boy. But according to how you make your curve here, it might be a little different for some people. So let me go with what I have. I have my x-axis value be what here? 0.5. This is your maximum point, top of the mountain, right? And this will be 7.2 because we counted in 2s here. I get 7.3 because I in between the line, right? But if you someone I get 7.4 or I get 7.4, go with what I have now. I go with what I have, right? So I have 0, so my max point would be 0.5 comma 7.3. But you can't work it out to know, but the equation of your axis of symmetry is simply a line which comes through the center of your curve and cuts that curve into 2 equal parts, right? So that equation is actually given by x is equal to -h, right? But the coordinates of your maximum minimum point would be given by -h comma k. You remember that? So you even have to look at the graph. -h is 0.5. So therefore, this axis of symmetry would be x is equal to 0.5. You don't even have to scroll up and watch the graph or even draw the axis of symmetry, right? But let me just give you all a visual on it, right? The axis of symmetry is simply be a line coming through the center of your curve, and this here is passing through where x is what? 0.5. So the equation would be x is equal to 0.5. How are we looking at Keegan? Now they said use your graph to find the solution of the equation -x squared plus x plus 7 is equal to 0, right? So there's something about your x-intercepts, right? Or your roots. I want to put this as a note. So note, the x-intercepts, the x-intercepts, write this down please, Yuvraj. right? Or I wanted to write the note, and I probably have it. The x-intercepts or the value of or values. This is supposed to be x-intercepts. The x-intercepts or the values of x when y is equal to 0 are the roots of the quadratic, right? So that word roots is very important, right? So if I ask you for the solution of the equation, right? The solution of your equation, well, your quadratic equation would simply be the roots of your equation, right? So your solution would be your roots. Okay? My roots are simply the values of x when y is equal to 0, or the values of x where the curve is cutting the x-axis. So let me see what it is from our curve above here. What you're getting there? I get 2.1, 2.2. Negative 2.2. And here would be negative 3.2. Sorry, 3.2. Positive 3.2. Right? So that would be my roots from the curve. Well, anybody get anything different on this?
I get last one.
Now we talk about. So negative 2.2 and 3.2. Those will be the roots of my quadratic now. So we need to, on the grade above, draw the line for the points negative 3, comma, negative 1 and 0, comma, 8. So while you're drawing this line, I'm going to find the gradient by the meanwhile, right? So what's the formula for gradient? M is equal to
Y2 minus Y1 all over X2 minus X1.
x1, y1, x2, y2. So that'll be what? 8 minus negative 1 over 0 minus negative 3, which will give me what? That'll be 9 over 3, which is 3. That's my gradient. So I need to draw the line. After I draw the line, I'll be able to determine where my y-intercept is. Remember, C is your y-intercept. Right? So let me go. So the coordinates of the 2 points that we needed to plot would have been negative 3, comma, negative 1, which is down here. Right? And negative 0 on the x, 8 on the y, which is up here. I drew a line passing through these 2 points, and it is a tangent to the curve at the point negative 1 comma 5. But what did the question ask us for? The question asked us for the equation of the line. So we know that the y-intercept is what? What is the y-intercept? C will be equal to 8. Alright, we know the y-intercept is 8, which is C. So let me scroll down. So we know C is equal to 8. So therefore, y is equal to 3x plus 8. That is the equation of the line that we just drew. So we on to January 2023, right? So the function f is defined as follows. They wrote it as f such that x maps onto x squared minus x minus 2. So I'm just saying that this format of writing a function is also the same as this format, which is also the same as this format. All three formats are the same. They said to complete the table below and plot the graph for the function f of x is equal to x squared minus 2, well, x squared minus x minus 2 on the grid as follows. So we have only 2 missing values, right? So let's just highlight something again. What are my x values? My x values are called my domain. My y values or my f of x values are called my range. Domain x values, range y values, right? Hey, look, they give you a scale up here. I don't know why they hide it here for. So don't forget our scale, right? Let me find these two unknowns now. When x is equal to negative 2, y will be equal to Look the quadratic up here. Y is x squared minus x minus 2. So y, or f of x, will be equal to negative 2 squared minus negative 2 minus 2. Where again there? Where get there, Liam? 4? Positive 4? Proper. Then the only other one that was missing is when x is equal to 0. So that means y is equal to 0 squared minus 0 minus 2. Y will be equal to what? Negative 2? Negative 2. Right? Okay? So make sure you have all your axes or your table written down, right? We have negative 2, 4, negative 1, 0, etc. coming on the road, right? So there we go. We're going to plot these bad boys. So 2 centimeters to 1 unit. So we come in here. 1, 2, 3. On this side, I'll have negative 1 and negative 2. 0 in the middle. Then I'll have 1, 2, 3, 4. I'll write my scale here one time. 2 centimeters to 1 unit on both axes. Alright, and down here you'll have negative 1 and negative 2. Alright, to work. Give me the first coordinate there, Eden. Negative 2, positive 4. Alright, let you go. Boom, that's up here. Let me draw my curve in red. Negative 2 and 4. Next. Negative 1, 0. So we on the x-axis. Negative 1 on the x, 0 on the y. Next. 0, negative 2.
Yes.
So we on the y. Next. 1, negative 2. So they didn't give us our minimum point again. Wicked boy. Next. 2, 0. Oh, we just mirroring on this side, right? And then we will be up here. It'll be 3 and 4. Right, boom. All right, let's draw a curve. All right. So we come in, so are we looking at Kia? Looking good? We looking at Mikel.
You can save myself.
Yeah?
Yeah.
Somebody asking something there? Right? So y is equal to x squared minus x minus 2. Right? All you realize I'm putting everything like how we coming on in this last stretch here. Long time like when you was doing these questions, you might have seen me leave out the scale. I might not even writing the title for the curve because we're moving with pace. But now we have to get all the little intricate things in to make sure that we maximize on marks. I'll join the graph, right? So the function number 8, this is January 2022. The function f such that x maps onto 3 plus 5x minus x squared, right? Complete the table of values for f of x is equal to 3 plus 5x minus x squared, right? So this means that we need to find for when, all our missing values, right? So we're doing for when x is equal to 0. F of 0 is the same as like y would be equal to 3 plus 5 by 0 minus 0 squared, right? Which will give me what? 3? You'll get 3? Right? And then, we could just put like f of 1. What's f of 1? F of 1 will be 3 plus 5 by 1 minus 1 squared, which will give me what? 7. And then let's find f of 4. F of 4 would be 3 plus 5 by 4 minus 4 squared, which will give me what? 7 again. And last one is f of 6. 3 plus 5 by 6 minus 6 squared would be equal to what? Negative 3. Right? So everybody have their coordinates, right? We have our domain, we have our range. Together they form our coordinates coming down the road, right? So on the grid below, complete the graph of f of x is equal to 3x, well not 3x, sorry, 3 plus 5x minus x squared for the domain -1 less than or equal to x less than or equal to 6. So CXC already plotted some points here for you all, right? So which one's missing? -1 and -3 is here. What's the next one? 0, comma what? 3? 0, comma 3, so that'll be here. Everybody good there? Which one is missing again? 1. 1, comma what? 1, comma 7. What is next? We added 2 9s and then 5. 5, comma what? Or 4. 4, comma what? Sorry. Same 7. And then the last one down here will be 6, comma -3. So let me draw the curve. Is this? Now I want. Glitching. There you go. Hey, these things has with my eyes, boy. Anybody do experience that? The lines does do something to my eyes, boy. Right, let me label this graph. What's the label? Somebody mic on. Y is equal to? Right, that's the label for my graph. I see the axis a whole bunch of things on it. Right, so the next part of the question is asking us to, we drew our curve above here, right? We put in the points that were missing, the coordinates of the points that were missing. We drew our curve and we put the labels for our curve, right? Write down the equation of the axis of symmetry for the graph, right? So your axis of symmetry will be given by x is equal to -h, right? In this question here, your axis of symmetry will simply be a line coming from top to bottom, and it passes through the maximum point here. So what is the x value here for this point? What it is? 2.5. All right. So in this question here, -h is actually just 2.5, right? So x will be equal to 2.5. This will be the equation of my axis of symmetry. All right. Okay. Indicating that -h is actually 2.5. Everybody clear there? We need the maximum value, which is the value of k now, right? So we need to know what k is, right? So your max value is equal to k, right? So let me see if we can figure out what k is here, boy. So what is this? This will be 9, right? Everybody agrees? So we counted in what? Point 0.2s, right? So 9.2, 9.4. Again, 9.3 again, or no? This is definitely in between. What y'all getting? 9.4. What y'all get there? I get 9.3.
So I get ECM 9.3.
Yeah, I get 9.3.
9.3.
Yeah. No problem, Jordan. Right? So, therefore, K is equal to 9.3. That is what I got on my graph, right? If you get 9.4, put 9.4. Right? Okay?
It's still correct.
Yeah. This will be a max value. Not either way now, bro, because CXC would more than likely see. Write down the coordinates of the point where the line y is equal to 3 minus 1 half x crosses the x-axis. When any line crosses the x-axis, what will be the value of y? When a line crosses the x-axis. So I'm basically, very good, I'm basically calculating the value of x when y is equal to 0. So let me plug that in now. If y is 0, what am I replacing y with here? 0 is equal to 3 minus a half x. Let me carry the half x on the side now. So to become positive. So this will be a half x. A half x plus 0 is just a half x is equal to 3. What do we do with the 1 half when we carry it here? We are going to divide, right? So x will be equal to 3 divided by 1 half, which will give me what? 6. So therefore, the coordinates, which is what they asked for, the coordinates would be 6, comma 0. Because look, y is 0, x is 6. So this would be the coordinates of the point where my line, this is a linear equation. So it is a line. So it cuts the x-axis at this point. So once again, when the line crosses the y-axis, the value of x is 0. So when x is equal to 0, y is equal to 3 minus a half by 0, y will be equal to 3. Right? So the coordinates of this point would be what? What is the x value here? 0, comma 3. Right? So on the grid above, draw the line. Draw my line. Bup, 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 bup. So you see why I had to bring this thing for you by Eden? Right? You see how much thing we still have to do here? 6, 6, comma 0. 6, comma 0 be 6 on the x, 0 on the y. So that's here. And 0, comma 3. 0, comma 3 is this point here. Right? So there we go. Boom, bang, boom, bang, boom, bang. What's the equation of this line? Y is equal to what? 3 minus a half x. Right? That's the equation of that line, right? So I think the next part of the question is to solve the two equations. Let me just see it here. Yeah, simultaneously. So I want to put a note on that, right? So to look, they said using the graph, right? So using the graph, determine the solution to the equation. So write this down. Note the solution to a pair of equations, right? It don't matter if it's simultaneous and linear, right? Equations are the coordinates. Well, I put in coordinates of the point or points, right? So it would be the coordinates of the point. It could be 1 point or it could be 2 points, right? Point or points of intersection. Right? So we just go down and list what x would be, the two values of x. So therefore, the solution would be x is equal to whatever, and well, it's two values, so x two values, so why? Because it's 2 times the line is cutting through the curve, right? So write this. So I am getting here x at 0, yes. So x will be 0 for this one. And x here is exactly 5.5 for me. Exactly 5.5. What are you getting? 5.6? Oh, I get exactly 5.5. What are y'all getting?
9.5.
Right what you have, eh? I get exactly 5.5, right? So mine would be x is equal to 0 and x is equal to 5.5 and y is equal to, what the y was? 3 and y is what? 0 point, I think it's exactly 0 point something for me. Exactly 0.2. Exactly 0.2 for me. Like exactly directly on that line. 0.2. This will be the solution to my pair of simultaneous equations. All right? Guys, we had some fun here.